So the tech's not working for me either, so things aren't quite the way I've arranged it to be. So I might be a little awkward here, but we'll make it work. So yeah, I'm Dave Klein. I am with Quix, which is a company that builds an event streaming platform for Python developers. I used to be with Confluent, who was created by started by the creators of Kafka. So I've been working with Kafka for quite a bit for the last 4 or 5 years, and I love it. And I've also been working with Python for the last couple of years, and I love that too. Before that, I used like 20 years or more of Java, and this has been such a relief. It's like, I feel like I retired already. You know, I'm still working, but it's like, doesn't feel like it anymore. So, and I also want to mention that it's great to be back here. Last year at PyTexas, that was my very first Python conference. I've spoken at hundreds of conferences, but it was the very first Python conference, and it was amazing, and it still is. So thank you all for the organizers and attendees. Yeah, it's just a great community. So, all right, so let's get started. Hopefully I can keep track with what I'm doing. And nope, I can't. So I'm going to talk about this projector. It's really a great projector. It's gone now too. I can't talk about anything. All right. We're back. Okay, so event processing, or real-time processing, or stream processing, you'll hear lots of different names for it, but it's basically talking about getting data into our applications, dealing with it right away as it's originated. And that's why I like the term event. You'll hear the terms event, message, record, when dealing with things like this. And those are all valid terms with for different use cases or different connotations. I like event because of the fact that it's tied to something happening. And that's really where all data originates, really. Something happens that generates data. And so the event tells us something happened, and it gives us the data about what happened. And as data is generated, that's when it's really most useful to us in most cases. Now, traditionally we get data, data is generated, it's stored into a database, and then we periodically run queries against the database to get the data out and do something with it. So the idea here, though, is instead to get that data as it's generated, and make use of it right away, doing the processing that we want to do on it, one event, one record at a time, in a continuous stream. So you can see like data be coming from different applications. It could be coming from IoT devices. It could be coming from mobile phones. It could be coming from all kinds of different things, sensors, all kinds of stuff that could be bringing data into our systems. And then we run it through some whatever processing we're going to be doing to it, and then output it usually to something else, some downstream process, a storage thing, analytics engine, something like that. So that's the common use case for these types of things. And speaking of use cases, I want to mention a couple. There's lots of different places where this is used, but some of the most common ones are things like recommendation engines, right? I mean, those are often done they've been around for a long time now, so ever since Amazon came on the scene, really. But these recommendation engines often early on would be done based on pulling data periodically, sometimes daily, sometimes hourly, different time intervals, but there's always a bit of staleness to that data. Now, most systems like Amazon and others like that are doing this in real time. So as you're browsing around the site, your recommendations are changing, right, by your current behavior, or the current behavior of people that you know through social media, things like that. So it's a little bit scary how much they know about us and stuff like that, but they're able to make use of that, hopefully to our benefit, using real-time processing. An example I saw, though, that hits me personally is, since I do a bit of traveling for work, you have like frequent flyer programs or hotel loyalty programs in general. And there's a hotel that I stay with, a chain that I stay with regularly, and if I stay at a hotel, it's usually about maybe a week and a half or so before the points from that stay show up in my account, which is no big deal. It doesn't really matter that much, but I just noticing that recently, the airline that I fly on, I landed in an airport, and I can pull up my phone, pull up the account, and I see the miles in my account right there. So you can see one of these companies is using real-time processing, the other one's using some type of a batch system, and it makes it a very different customer experience. And again, those aren't life or death situations, but they do make a better experience. So it's one of those things where we may not see right now, we were just talking earlier, but we may not see right now the use cases for this, but they start to appear more and more the more we learn how real-time processing works. And also as it gets easier to do, just like machine learning. There was a time when that was a real niche thing only for a few use cases, and now it's used everywhere, right? Because it's gotten easier to use and we understand it better. So when talking about this, I'm coming from the Apache Kafka background, but that's not the only tool that's used for this type of for event processing or stream processing. There's also tools like Apache Pulsar, which is similar in structure, but based on some different underlying technologies. There's Red Panda, which is basically Kafka, but written in C++. And then Amazon Kinesis is another pretty popular one. And there's some others as well. But these are different tools for event streaming or message brokers or things you might want to call them. Not to be confused with message queues. That's a really different animal altogether. So I wasn't bringing those into it. And then for the processing part of it, I was going to say, close it off with saying Kafka really is the de facto standard, though. So it's what I'm going to stick with. It's what I'm most familiar with, but it's also the one that's most commonly used. So if you're getting into this to start out, Kafka is a great place to start with. To do the actual processing, there's whole frameworks that have been built up to do real-time processing with data in these event streams, like Apache Flink, which is a pretty popular one. This is an application that you have to install. You usually run it in a cluster with several nodes, and you write applications in SQL, or using PyFlink, you can use Python. And you write your applications and then run them against the ongoing stream of data. Another one is KSQLDB, which again uses SQL to works against Kafka data. Or if you want to include something in your applications, there's libraries you can use. The most popular one is a Java-based library called Kafka Streams. It's actually a part of the Apache Kafka project, and it allows you to just include some classes in your application and do real-time stream processing in your own applications, your microservices or other applications. Whoa, this thing's pretty tense sensitive. But you can build those things into your application instead of having to have another set of applications running in their own cluster somewhere. So that gives you a lot of flexibility and saves a lot of money as far as the process or operationally. But it's Java, and that's not great. So there are some, and in the end, I'm going to talk about some other libraries that are for Python that do similar things to Kafka Streams. But the goal of this talk was to show that you can do some simple stream processing things with just plain Python and Kafka. So back to Kafka. So before we get started, I did speak on Kafka last year, and so I actually am going to reuse a few slides here, but I'm going to do a really brief introduction to what Kafka is, just for people that aren't familiar with it. So if you are familiar with Kafka, please bear with me. It shouldn't take too long, but I just want to make sure everyone understands what we're talking about. So at the core of Kafka is a log. Really, Kafka is a storage engine for the most part. The real magic happens with the client libraries, which are producers and consumers. We're going to talk about those in a bit. But underlying Kafka really is just a log of data. It's an immutable, append-only, ordered, and durable log of events. And these are important characteristics of it. So it's immutable in that when something happens, it stays happened. You can't undo it. You can add something. It's kind of like with accounting. There's an essay, like Why Accountants Don't Use Erasers, I think it's called, which talks about this whole idea that when events happen, they happen. You can't undo that. You can do another event that counters what the other one happened. You can adjusting entry type of thing, but you can't undo the thing. So when something lands in a Kafka topic, it stays there. It's append only, so we don't insert anywhere. It always just keeps on adding on. And it's ordered in that what you're seeing here on the screen is a single partition topic. So Kafka topics can be broken out into multiple partitions, and they usually are, but they don't have to be. But for each partition, it's its own log, and the data in that log will be processed in the order it was written. So just right to left, keep on going, and yeah, so that's ordered, and it's also durable. And this is a real key feature, and it really makes it differentiate between queues, which usually lose the data as it's consumed or processed, right? A Kafka topic keeps this data as long as we want it to. We can set the retention through configurations, so the older data can drop off when we don't need it, but you can also just have it stored permanently, especially with mechanisms now like infinite storage, where you can have older data moved up to S3 or something like that, and cheaply store all of your data permanently. But you don't have to. You can set retention to drop it off at a certain age period, but the data is there as long as we want it there. It doesn't disappear once it's been read. That's the key thing there. And this comes in handy for things like replaying, and if you're or like for machine learning models, your training model, you repeat the pipeline with the same data over and over again. You have consistent results because you have the same data. That number you see at the bottom of that screen of the log there is an offset, and so you can reset to any offset and just replay from there forward. So it's really helpful for retrying things, for fixing bugs and then replaying the data, or doing what if scenarios, things like that. All right, so here's just a random representation of what an event might look like in Kafka. In Kafka, it's actually just bytes, but in our applications, it's going to usually be some type of an object that can be serialized to bytes. So either maybe a protobuf or JSON or something like that. Here we have a JSON example. It's got the two main components of an event are a key and a topic, or key and a value. Sorry. So the key is normally a simple data type, a string or something like that. It might be a UUID, it might be a customer ID, something meaningful in your domain, but it's usually a simple value and then or simple type, and then the value is the more complex type. That's going to have your fields in it. It's more like your payload. Now it's also, I don't mention it here, but also every event in a Kafka, or every Kafka event will have a timestamp, which is also really important, especially if you're working with time series data or things like that. All right, so these events are written to the Kafka topics using a producer. Now, a producer is a class in the client library. Excuse me. And we're going to talk about a couple of different Python client libraries that are out there. But all client libraries, in whatever language, are going to have these classes. So producer is one of the main classes. It is one that's responsible for writing data to the Kafka topics. It'll also handle things like compression. It'll handle retries. And also, if you're working with multiple partitions, the producer is what figures out which partitions to send each event to. So these are all important things that the producer does. And the producer is just a class in this client library. So as it writes the events one by one, it keeps appending to the next open offset. Then the consumer comes along. The consumer is another class in the client library, and the consumer is what will read the data. It's kind of, I think, misnamed because it doesn't consume the data. We mentioned earlier the durability, right? The data stays there, but the consumer will read the data and then do whatever processing we want it to do. We handle the processing because it's in our application. It's just a class we're including in our application. So we decide what we do with the data. The consumer just reads it for us. And so the consumer reads from left to right, just following the same path, but they're completely independent. The producer doesn't know if someone's consuming the data or when, and the consumer doesn't know where the data came from. They're completely decoupled, which is really important and allows us to build much less coupled applications. Now the consumer will also periodically record the offset number for the most recent event that it's completely processed. You can do this automatically through configuration, or you can do it in your code when you know you've completed a certain one. And this is important for making sure that you don't skip anything and that you don't do duplicates. So if the consumer goes down, the producer will keep on going. It doesn't really know the difference. It'll keep on producing, and then eventually there is a metric you can watch for here called consumer lag. So if the consumer gets too far behind in reading what's on the topic, then you can set up alerts for things like that, so you know something's wrong with your system. But the application won't fail because of it. Which is, if you remember last year in my talk, we talked about event-driven microservices, and that's really a key thing there, so that a failure in a consumer doesn't cause a cascading failure downstream. But when it starts back up, it'll use that committed offset to pick up at the very next spot and keep on going. So. All right, so that's all I had on the producer and consumer. Like I said, those are part of the Kafka client package, and there are two popular ones that I know of in Python. There's the Confluent Kafka, which is the one that's produced by Confluent. It's based on, basically it's a Python wrapper around a C library called librd Kafka, which is pretty widely known or accepted to be the closest in both performance and features to the Java client that comes with Apache Kafka if you download it. So it's a pretty good option for that. It's well maintained. They keep on top of it. And it's not fully open source, but it is. So I talked with someone before at a conference he's from Wikimedia. They can't use this package because it's not fully open source. It's one of those licenses where you can use it for anything you want as long as you're not competing with them in the cloud. But because of that little caveat, companies that are fully open source only can't use it. So for that, there's also Kafka Python, which is just a community one that is fully open source. And also, I haven't worked with it very much, but what I've seen and heard from other people is it is a bit more Pythonic, since it's written purely in Python and it follows more Python idioms and things. But they both have the classes that we're going to talk about here. I keep getting confused. I'm seeing something different on my screen when I look. It's down here. Okay, So here's an example. I'm going to step back here so I can see what I'm talking about a little bit. This is a real simple example of a Python producer writing data to a Kafka topic. So you see we just import the producer class, and then I'm setting up a couple of data bits there. It's just a key and a value. They could be anything, but I just want to set something there for the example. Normally this data would be something that's generated from a process that you're already running. It's not something you're going to create just for the purpose of writing it to Kafka, but this is just for my example. So in the constructor, there's only one. You pass the constructor a dictionary. And you'll see a lot of examples, and I may be off on this one, but a lot of people use like YAML files, things like that for the configuration, and then they have a bit that reads that in and converts it to a dictionary and then passes it to the constructor. And I don't know why they don't just use dictionaries. I love dictionaries. But anyway, so it just takes a dictionary, and you can put a ton of stuff in that dictionary. There's a lot of configurations that you can set on Kafka producers and consumers. There's only one for the producer that's required, and that's the Bootstrap servers. The Bootstrap servers tells your producer class, where can I find a Kafka broker? Now, Kafka normally runs in a cluster, so you normally have multiple brokers, usually a minimum of 3, but some companies will have hundreds. And you only need one here, because if the producer finds one broker, it will return that call to the broker will return the metadata for all the brokers in the cluster. So it'll get everything it needs from there. That's one thing that Kafka's really good at, is communicating between different brokers, different consumers, all the different components that are running. They keep each other in sync of things pretty automatically. And then once you construct the producer, then you just simply call produce. You can also, there's callbacks you can give to it if you want to make sure that the thing was sent properly and things like that. But the basic use is just call produce, give it a topic. Really, all you have to give is a topic and a value. The key is optional. I included it here as well, but so you pass in a topic, it's always the first argument, and then actually the second argument is value and then key, but I don't like that order, so I put them in with named arguments just so I can put them in the order that I'm more comfortable with. But and that's all there is. So that's going to send that data to the Kafka topic called my topic. All right, so now this is normally something that would be done over and over again through some other process that you're running, and I just lost it again, huh? It's because this time I think it's because my laptop went to sleep. We're back down here. Oh, yay. I guess I'll just touch this once in a while so I don't lose. You know, it shows I'm talking too much on a single slide. We talked about that earlier, right? I shouldn't be staying on one slide for too long. So that's getting data into Kafka. And now consuming data from Kafka. It's similar. You import the consumer class, and the consumer also takes a dictionary in its constructor. That dictionary is going to have the Bootstrap servers again. That part's the same. But there's one other required property in the consumer, and that's group ID. So you don't always have to use a group. Let me explain briefly what consumer groups are. They're really a powerful feature of Kafka. A consumer group allows you so you can have multiple instances of the same consumer application running, and they'll automatically share the workload of the data that they're reading. They split by partitions. So if you have a Kafka topic and it's got 4 partitions, you can have 4 instances of your consumer class running, of your consumer application running, and each of those will read from one partition. So that the data stays processed in order by partition like the guarantees are, but the workload is split across 4 now evenly. If one of those consumers dies, then it'll automatically rebalance and give that orphaned partition to another consumer that's running. Or if you have 2 to start with, it gives them each 2, and then you get busy, you start 2 more up, it automatically spreads those out again. So the balancing up and down, so scaling in and out, is all handled for you automatically with a consumer group. So it's really a powerful feature, but to use that, you need to have a group ID. Now, if you're not using a group and you're going to have just one instance of your application, then you technically don't need a group ID, but this particular client requires it anyway. So those are the 2 things we put in our dictionary that we pass to the consumer's constructor. And then the next step we have with the consumer, now we notice with the producer, we tell it in our call to produce, we say what topic to send it to. With the consumer, you don't do that. With the consumer, you subscribe to 1 or more topics. And then when you call pull, which we're going to do down below, it will pull from the topics that it's subscribed to. So here we're just subscribing to a single topic called my topic. So I put it in a list of 1. It does have to have a list in that subscribe call. And then we just jump into a loop, and we're going to call the consumer.poll. Now poll will read from the topics. If there's more than 1 topic in that subscribe, it will read from each of them one after the other, kind of in round robin fashion. And with each call to poll. And then the value I'm passing in there is a timeout. That basically says, check. Nope, did it again. I'm talking too much. But I'll keep talking while I do this. So what it'll do is it'll try grabbing data from the broker, and it'll keep trying until it either gets data or until that time is hit. So after 1 second in this case, if there's no data, it'll just return none. But if there is data, it'll return instantly as soon as the data is there. So it doesn't slow you down to having a value here. This just tells you if you want to leave the connection open to give it a little time to get data, you can do that with that value. And then so the event can be none, or it can have a value, or it could also have an error. So I didn't include it in the slide here, but you can also check the event.error, and if there's an error, you could do error handling. Then you can just grab the event value, which I'm doing there. And I mentioned that in Kafka, events are all bytes. So the value is a byte, the key is a byte, everything's just bytes. So I'm decoding it here. There's the library actually includes serializers that you can use to serialize and deserialize most of the basic types. And you can also use serializers that work with things like protobuf or Avro or JSON schema, things like that, to do your serialization. Or you can write your own serializers. There's lots of ways to get the data from bytes back to something useful. In this case, I'm just using decode and then printing it out. So simple example, but that shows you how to use a Kafka consumer in Python. So we'll have some slides later where we're going to show some examples of some streaming operations, and the consumer, all this stuff will be assumed that it's happening. In fact, that's where we're going to go to next. So stream processing. So the goal here of this talk is to show that stream processing isn't that hard. There are libraries and frameworks and all things like that to help you with it, but you don't always need those. And especially getting started, you don't need them. So I thought this was important because I think that stream processing can be very helpful to a lot of organizations, a lot of projects, but people think they get scared off from it thinking they need to have all this heavyweight stuff to do it. And I just want to show that you really don't. You can do quite a bit with just plain Python code. So operations and streaming are broken into two categories: stateless operations and stateful operations. So I'm going to show a few stateless operations first. Some examples of those. So the first one we're looking at is filter, which is a pretty common one actually, and that's where you got a stream of data coming in, and you want some of that data, but you don't want all of it. So you want some events and some, not all of them. And so based on some data, some value in the event, something maybe in the value or maybe in the key. Usually it's in the value, but somewhere you make a decision whether you want that event or not. And so you just basically you're pulling on it, and for each one that you get, you check it against whatever your predicate is. So I wrote mocked out a check predicate method. That could be anything in there. That could open up the value. It could check a certain field if it's greater than this or less than that. It can make whatever distinctions it needs to, and it returns either true or false. And if it's true, then that event goes on to the next step. If it's false, that event gets skipped. So simple enough, and then we produce it to an output topic. And this is a common theme. A common pattern you'll see in stream processing is that you have an input topic and you have an output topic. And then you do something in between there. So that's a filter. The next one is branch, and this is a really helpful one. This allows you to take one stream of events and break it into multiple streams of events. And again, this is a feature that's built into most of the streaming libraries, like Kafka Streams. I used to work for an insurance company that had they used to call it the fire hose topic. It was a single Kafka topic with, I think, 1,000 partitions, and all events coming into their organization came through that topic. And then we had a Kafka Streams application that used branch to split those out into a whole bunch of different topics based on the data in them. So it basically gave them a way to log and monitor all the data coming in before they send it off to the downstream applications, which are based on departments and things like that. But we can do the same thing, which is Python. We're just using either ifs, or you could do a switch or something like that. But so we check the different predicates. I've got two of them here. If it meets the first one, it goes into topic or output topic A. If it meets the second one, it goes into B. And these are ordered, so it'll hit the first one it hits, that one's gone. It won't check the others. And then we have a default one, which you can have or skip. You can just ignore the ones that don't match your predicates at all. Or you could put all of them into a default topic. But this just allows us to take that one incoming stream and split it into multiples. And then again, put that to another output topic. Now, I'm showing these going from an input topic to an output topic, and that's pretty common to do another topic for each step, but it doesn't necessarily mean it's the only thing in that application, right? So you might have multiple steps like this in one single application where they're reading the output topic of one process becomes the input topic for the next process. And you connect these together with nodes, and basically in a directed acyclic graph is what it turns into. So that's a branch. And then map. So the map is basically you're just going to do something over every event in the stream as it comes through, right? So it can be whatever you want. So and this way I just have my func. And rather than even doing the whole poll thing, I just have, rather than reading the event in the polling loop, I just go ahead and call my func in the polling loop, and just pass the poll method result into that. So that my func can be any kind of transformation really. So you might be taking something like JSON data and flattening it out to CSV or something like that. So changing the shape is a common use. enhancing the data. So maybe if you got like a lookup table that's loaded into memory that you can quickly call and enhance the data with each event as it's coming through. That's another thing that's commonly done with map. So this is another really popular feature. And it's, again, the streaming libraries will all have things like that for you, but we can pretty easily do it just with Python. Okay, now let's switch over to the stateful operations. And these are a little bit more complex because these other ones, each event that came in, as we're processing each event that came in, we didn't care at all what happened with the event before it, right? It didn't matter. Each one is handled independently, completely. Now we do care about what happened before because now we're dealing with things that involve past state. For example, counting. Oh, by the way, speaking of counting, I'm actually using this one in my demo app if I have time to show, which I might run out, I'm not sure. But the demo app has to do with Twitter, so you should right now be tweeting about PyTexas. If you tweet about PyTexas, you'll show up on the leaderboard in a minute, hopefully, if I can get that to work with the screen and all that stuff. And somebody has to start going to beat Andy Knight, because right now he's the top. I know, I'm going to do another version of this that pulls from Mastodon as well. I didn't have time to get that together for this. Sorry. All right, so let's take a look at count real quick. And I'll try to move through these ones more quickly. So the key difference here is that we need to have someplace to store state in between events, right? For a count, we're going to be accumulating an account for each key. And so we need to have someplace to store that. So dictionary to the rescue, right? It works great. So for each event that comes in, we check the key to see if it's in the counts dictionary. If it is, then we go ahead and grab that item in the dictionary and increment its value. If it's not, then we add it to the dictionary and give it a value of 1. And just keep on going through. And as we do each step, we also produce it to the output. So we produce it to the output at every step so that the output topic will always have the latest value for each key. And if this is a little bit off topic, but Kafka has a really cool feature called compacted topics, which are topics that don't have every event ever. They just have the latest value for each key. They have some others too, because there's a cleanup process that takes time to get rid of them. But they guarantee to have the latest value or the current value for each key. And that's perfect for storing things like count results. So we produce it after each call, and it just keeps that accumulating count, like a count of tweets by a specific user. So that's count. Sum is another common one. And again, we use a dictionary to hold the sums. So it's really similar to counting, except instead of increment by 1, we're going to just add the value for each new event. We're going to add the value to the value before with the same key. So this is all tied to the key of the event. You could actually use a certain field in the value. It'd be a little more complicated, but you could do that as well. But the key is the most common way to aggregate these things. So other than that, it's basically the same as the count. And then aggregate, which again is similar. We're gonna do some type of a generic aggregation, something that's gonna work on all of them together. So one thing is an aggregation might be used for that's different than counting or summing would be like compiling them into an array. So you want to take a bunch of individual events coming in, and you want to create a bunch of arrays of those events, or lists of these events. You could do that with aggregate. So the events come in, we have an aggregate dictionary called ags here. We just check to see if this one we don't even need to check to see. We just keep on passing the value that's in the dictionary along with the event value. And if it's not there yet, then it'll just have a none, and it'll work on that. So, and all these ones here, I'm not doing things like error handling and stuff like that. These can be done inside the functions that get the data, or they can be done in this loop as well. So it's easier to show it here by assuming that stuff's all being handled in the functions. So that's that one. And then a join is trickier, but it's still doable. What we have here now is we have two different input topics, and we're using two different consumers. We're going to pull each consumer. You can actually do this with one consumer and subscribe to both topics, but it's a little bit more confusing, so I thought it was clearer to show with just two consumers. So for each consumer, we'll start with the first one. We pull that topic. If we get an event, and we check to see if the key to that event is in, if it's in the B dictionary. So if the key to the A event is in the B dictionary, then we can make our join there. If it's not, we've added the A event already. So if it's not there, then we just go on and skip. But we actually check to see if it's in the B dictionary and if it's not in the C dictionary. The C dictionary is going to be the source of our output. We're basically taking two events that have a similar key or the same key. We're going to join those together. Maybe we'll create a new type of object that has only some values from each. kind of like you would with a SQL join. And that new object will go into the C topic. And so if it's not in A, the join doesn't happen there, but the A value is stored, so it's sitting there, and then the B one comes, and if the B one looks in the A dictionary to see if it's there, and if it's there, it makes the join. And also if it's not in the C dictionary. So as soon as it lands in the C dictionary, then that's going to not happen again. So you won't join it multiple times. Now, the one challenge with this is this works fine. I've tested it out, but your dictionary will grow forever. So you want to probably add something in there like in a scheduler or something that can remove some excess things. But you can even do joins. These are all things that are challenging to do without a library to help you, but they're possible. So I just want to show these things are possible, give you some ideas, and I will try to start wrapping it up now. Oop, yeah, that's the thing for the next sign, right? 2 minutes now already? It was time now? No, how'd that happen? Boy. Okay, let me real quickly. I've got some code on a GitHub repo, which I can send to anybody they want to see the code, because I don't really have time to go through it. I will only show just one bit of it. I can't even do that because the slides. You know what? Let's skip that. I can't show the code because it doesn't show up on the screen. I'm hoping I can drag my browser over there and at least show you the latest stats here. Give me 1 second. Oh no. Technology hates me today. The internet's down too, so. Let me just real quickly get on my hotspot. Maybe you can come here to one of those jokes for a second here. Oh. Anybody got a joke? And don't say my talk, please. You were thinking that? Yeah, right. Oh, that is good. I like that one. I'm going to borrow that one for later. Come on now. I know I have a hotspot. It was working earlier here. All right, here we go. Oh, here we don't go. All right, let's see if we can pull this over. How do we pull that to that other screen? Oh. All right. So what do we got here? Andy and I still tough to beat with 13. But there we go. So this was doing is it's been pulling from Twitter every few minutes, checking the tweets for the PyTexas string, and then just using the count like we showed earlier. We're using the user ID of the tweeter as the key, and we're just incrementing the count every time we see a tweet from that person. We also have a dedupe step because the thing I'm using to pull the tweets in just does it pulls in duplicates. So it was easy to add a dedupe step in there as well. So again, you can add multiple steps to your processes, and that's what I was going to show you in the code if I had time. But like I said, the code's on a GitHub repo, which I can send anybody the link to if they want to look at it later. But this was all done with just Python with no libraries, Python and Kafka. They work great together, and you can do a lot with them. There are libraries, though, so just one more second here. How do I get back to what I had? Just like that. Yep. Okay, it's a challenge. State is a challenge. It really is, because we do dictionary, but those are just in memory. So a lot of these libraries have persistent state, which is important. And then scale. I was only working with a single topic or single partition topic for all my things. If you have multiple partitions, those dictionaries it's harder to keep in sync. So there are things that these libraries will help you with. Like I said, you don't always need them, but there are times when they do come in handy. So here's a few we can look at. There is Faust, which is originally started by Robinhood, then they kind of dropped it, and then the community picked it up, and it's still going somewhat. BiteWax and Fluvio are two newer ones that are out there. I think they're both REST-based, but those are also streaming libraries for Python, and you can find those things out on GitHub. And then quick plug for the one that my company puts out, the company I work for now, Quicks. They have Quick Streams. They just open sourced it about a month ago, so it's still pretty new, but it also handles persistent state and different things like that. It also works with time, really works well with time series data. and you can find information there about that. And it would be great if you would check that out, because then they might keep sending me things like this. So, but anyways, I thank you for letting me go a little bit over time, and that was my talk. And